The old name is a hollow frame. Ember whispers in the long dark. I breathe the wind in the tall grass. Light refracts 1,000 new selves.
Have you ever noticed those little metal weights clipped onto the rim of your car's tire? Ever wondered what they're for? They're not just for decoration. They're the solution to a really fascinating problem in physics and mathematics. A problem that forced engineers to step into the world of the imaginary, and this journey into the imaginary might just change how you think about reality itself. So let's talk about wheels. A wheel spins around its axis, right? Simple enough. But what happens if that wheel isn't perfectly made? What if the mass isn't distributed evenly all the way around? You might think it would just wobble a bit, and you'd be right. But the why behind that wobble is where things get really interesting. An unbalanced wheel doesn't just wobble. It tries to spin around a completely different axis. Not the physical axle it's mounted on, but a new, invisible axis that passes through its true center of mass. This is the axis the tire wants to spin around, its natural axis of rotation. The problem is, this axis isn't real. It's not a physical object, it's an imaginary axis. So you have this conflict. The physical axle, which is real, forcing the wheel to spin in one way, and this imaginary axis, which is also real to the laws of physics, pulling the wheel to spin in another way. The result is that familiar, annoying, and potentially dangerous vibration you feel in your steering wheel at highway speeds. This isn't just a minor inconvenience. It can cause uneven tire wear, damage your suspension, and make your ride incredibly uncomfortable. This phenomenon is what we call a dynamic imbalance. The wheel is out of balance while it's in motion. How do we fix a problem caused by an invisible, imaginary axis? Well, we can't just tell the tire to ignore physics. We have to work with it. We have to bring that imaginary axis back into alignment with the real physical axle, and to do that we need a tool that can handle the imaginary mathematics. Specifically, we need a type of number that scientists and engineers once considered purely theoretical. We need imaginary numbers. Now, if you haven't thought about math class in a while, the term imaginary number might sound like a joke. How can a number be imaginary? But it's a very real and powerful concept. An imaginary number is based on the square root of -1. If you'll remember, you can't take the square root of a negative number in the real number system. But mathematicians said, what if we could? They created a symbol for it, the letter I, and an entire new branch of mathematics was born. For a long time, these were seen as a mathematical curiosity, a fun puzzle with no practical application. But then, problems like our wobbly wheel came along. Physicists and engineers realized that these imaginary numbers were the perfect language to describe phenomena that exist in more than one dimension, like rotations and waves. They could use equations with I in them to model the behavior of the unbalanced wheel. The math allowed them to precisely calculate the location and effect of that imaginary axis of rotation. It wasn't imaginary to the tire. The forces it generated were very real. The math just gave us a way to finally see it and understand it. Once they could model the problem using imaginary numbers, the solution became clear. The math told them exactly how much weight they needed to add, and precisely where on the rim to add it, to counteract the imbalance. By strategically placing those little metal clips, they could shift the wheel's center of mass. Their goal was to move that imaginary axis, the one the tire wanted to spin around, until it lined up perfectly with the real axle. When the imaginary axis and the real axis become one and the same, the wobble disappears. The dynamic imbalance is corrected. The balance is restored, but only while the wheel is in motion. So think about that. We use imaginary thinking in the form of imaginary numbers to solve a very real-world problem. Those weights on your tire are the physical manifestation of a mathematical solution that started in an abstract, imaginary world. They are proof that sometimes to understand and fix reality, We have to look beyond what we can see and touch. The axis was real to the tire, but we needed imaginary numbers to make it real to us. This brings me to a much bigger question, one that goes beyond engineering and into the realm of philosophy and maybe even the paranormal. If science, the very discipline we rely on to define reality, has to venture into the imaginary to solve problems, what does that say about our definition of reality itself? For centuries, cultures all over the world have had beliefs and stories about spirits or ghosts. They see figures, hear voices, feel a presence. To the person experiencing it, the phenomenon is real, but for many, because we can't measure it with our current scientific instruments, because we can't write a mathematical formula for it, it must be imaginary. It's dismissed as a trick of the mind, a hallucination, or misinterpretation of natural events. But let's look back at our wheel. The imbalanced axis was real in its effects, even though it was physically non-existent. It was a ghost in the machine. It took a new way of thinking, a new mathematical language for us to acknowledge its existence and interact with it. Before the discovery of dynamic balancing, a mechanic might have just said the car was haunted or cursed. They could feel the effects, the vibrations, but they couldn't see the cause. They were missing the conceptual tools to understand it. So I ask you, are we in a similar position when it comes to things like ghosts? Is it possible that there are aspects of reality that are just as real as the forces acting on an unbalanced tire, but we simply have undeveloped the right math or the right physics to perceive and understand them yet? Many cultures don't need a mathematical proof to believe in a spirit world. Their reality is defined by experience, tradition, and intuition, not just by scientific equations. Is it possible that the line between real and imaginary is not as clear-cut as we think? That what we call imaginary today might just be the real that we have unfigured out how to measure yet? The story of the dynamically balanced wheel shows us that what once seemed purely imaginary can become a fundamental part of our practical, real-world technology. The imaginary axis was real, but also not real all at the same time. It's a paradox. This entire line of thought is what we're going to explore much, much deeper in our next episode. We'll be diving headfirst into this question: are ghosts real, or are they imaginary? We'll look at the evidence, the arguments, the science, and the beliefs. So if you found this journey from wobbly wheels to the nature of reality fascinating, you won't want to miss it. Thank you so much for watching and for thinking along with me today. Make sure you're subscribed and have notifications turned on so you don't miss our next episode where we seek the answer. See you then.